Hey guys, here will be the second video on integration by parts. So this is what you would have missed on Thursday and on Friday. So about halfway through the class on Thursday, we started talking about what's called integration by parts. So looking at integration by parts, the first thing we talked about was basic rules and procedures. Why what we know so far can't work for everything else that's out there. So let's say we're looking at something like x times the natural log of x in the integrand of an integral. Well, you might think that a little bit of u sub would work. Maybe you let u be the natural log, or maybe let u be x, but you'd see that by doing that, du would never cancel the other piece. The same thing can be said for something like x squared times e to the x. Maybe it looks pretty simple, but if I were to let x squared be u, or if I were to let e to the x be u, again, du is not going to cancel the other piece. So we need to have some kind of other strategy to deal with these kind of integrals that we wouldn't be able to handle otherwise. And that strategy is called integration by parts. And integration by parts is exactly like what it would sound like. Instead of just having u sub, what you're going to do is you're going to integrate by parts by designating two parts. And then by designating the parts, both u and v. So here we're not just doing u sub anymore, we'd also have to add this component of v. If we can find out what u is and we can find out what v is, then the formula for integration by parts would say that the integral of u dv is uv minus the integral of v du. So the book here would say, the guidelines would say, try letting dv be the most complicated portion of the integrand that fits the basic integration rule. And that's not necessarily wrong, that's how I was taught, but I think there is a better way to kind of go about it. So remember this formula, that the integral of u dv is equal to uv minus the integral of v du. Especially this uv part. What I think about when I think of UV, I think of UV rays. I think of light rays. I think of light rays, what do they do to my eyes? Well, they make my eyes dilate, or my pupils constrict and dilate. And dilate is actually the neat little acronym that I have for doing integration by parts. So ILATE stands for inverse trig functions, logarithmic functions, algebraic functions, trig functions, and exponential. This would actually be the order that you should go in when you're designating something for u. So if you're going to be letting something be u, start by putting anything that you see in terms of inverse trig. If you don't see any inverse trig, you go on the logs. If you don't see any logs, you go on algebra, and you keep on going that way. And again, the way I remember it is if you put a d in the front, it's dilate, just like what your pupils would do if they're looking into the sun. And if you go back to the formula and take a look at it, we see that the first part of the formula is uv. So I think that's a neat little way to remember it. Maybe it's cheesy, maybe it's corny, but I found it to work for me in the past. So that being said, we would have one more slide that we could talk about before we jump into the examples. And again, it's going to be dilate as the memory cue, and just kind of think about your pupils, and that should be able to help you with the UV light rays and the formula itself. So that being said, we can jump right in and see what one of these examples would look like. So in the beginning, if I was you, I would just start off by writing out the acronym and then just kind of going through the acronym piece by piece. So I would start with ILATE. You could also look at this integral and say, well, if I did regular old u sub, I don't think it's going to work. By letting u be x or letting u be e to the x, du again would not cancel. So I'm going to run through the process, right? I know the ILATE is my acronym for doing this integration by parts. I don't see any inverse trig functions, so I would skip on the logarithmic. I don't see any logarithmics in my integrand, so I would move on. Algebraic. Algebraic would be everything else that is not classified as inverse trig, logarithmic, trig, or exponential. So for this one, algebraic would be the x part. If you're looking at e to the x, that would actually be the exponential, and that would be the last thing you would want to designate as u. So in this case, I would set up u, du, v, and dv. This would be the process that you'd have to go through. So I guess the u du would be something that we're kind of familiar with regular u sub, but here would be the new part. If you're doing integration by parts, you need to have a second part with v. And an easy way to tell the difference, let u's have your little line going downwards, where your v's would not have the line going downwards. Don't try to do u's and v's like this, because you will see at some point that you will make a mistake or lose track of it. So that being said, let's let u be x. So if u is x, then dv would be whatever's left over. This would be the e to the x dx. So I would say dv is e to the x dx. And then I have to find du. That's not bad. The derivative of x is just 1 dx. And then v would be the antiderivative, or the integral, of e to the x dx. We know that e to the x is its own derivative and integral, or antiderivative. So v would have to be e to the x. So if you can do this little process right here, then we just use the formula. We say that if we want to find this integral, we know the formula for integration by parts is u times v minus the integral of v du. So here you've got u times v, x times e to the x. I'll say x times e to the x. minus the integral of v, which we know is e to the x, times du, which is 1 dx, or just dx. And then if you look at this part, you can kind of see you still have one integral to do, or one antiderivative to find, but this antiderivative is much more palatable. We know that the integral or antiderivative of e to the x dx is just itself, so for a final answer you could say, just kind of bringing this along, x times e to the x minus the antiderivative of this e to the x dx, which is just e to the x, and of course you would need a plus c to appease the gods. So taking a second to look at it, this would actually be your final answer. Make sure to include the plus c's. We've got kind of an indefinite integral, so with no bounds there needs to be a plus c, and then we would have completed integration by parts. So there's your first example. Again, feel free to stop the video at any time and go back and look at it again, but let's see if we can make sense of a couple more. So if that's okay, we'll take a second to look at the second example, which will be this guy right here. So looking at this one, you've got x squared times the natural log dx. Again, I would kind of just run through the acronym first. In terms of inverse trig, I don't see any. Logarithmic, I do. So here in this case, I would say let u be the natural log of x. So then I got du, v, and dv. So if u is the natural log of x, then dv is whatever is left over. So this would be x squared times dx. So I'd say x squared dx. So for du, we know the derivative of natural log is just 1 over x. And then if I integrate it or find the antiderivative for x squared, this would be x cubed over 3. So putting it through the formula one more time, we know this is u times v minus the integral of v du. So the natural log times x cubed over 3, or 1/3 x cubed, would just be 1/3 x cubed times the natural log, minus, and then here we have x cubed over 3. So you could say this is 1/3 x cubed times 1 over x. What I would like to do is say, since it's a 1/3 as a coefficient, just put it on the outside of this integral that you'd have already started. So minus 1/3 the integral of v, which is now just the x squared because I pull out the 1/3, and then I got to times it by 1 over x. And again, the du should also have a dx on it, so that will allow us to actually now do this integral or find this antiderivative. So that being said, let's see if we can simplify it one more little step before we finish it. So I'm going to say this is 1/3 x cubed times the natural log of x minus 1/3, well, x cubed times 1 over x, one of the x's would cancel, or you could subtract one of the, you could say 3 minus 1, do subtraction in terms of the exponents, and you'll have the integral of x squared dx. That being said, you can finish it off by just finding what the antiderivative for x squared is. Well, that's really not that bad. This would just be x cubed over 3. So if you wanted to, you could say, well, x cubed over 3 times your 1/3 will be 1/9, so it would be minus 1/9 x cubed. So if I was going to say a final answer here, I would say 1/3 x cubed times the natural log of x, and then I would say minus 1/9 x cubed plus c. That being said, this would be your final answer. And again, you've completed by integration by parts, because otherwise regular old u sub here would not have worked. That being said, let's see if we can do one more example, and that would have been what we completed on Thursday before we left class. So the last example we would have done on Thursday before we left class is this one here, and this would be arc sine of x dx. I think for Thursday we said we were kind of running out of time, so we let it be an indefinite integral, so we kind of crossed out the bounds. We'll handle that maybe at a later time, maybe tomorrow, which is Monday. So what we can do is just kind of focus on just the indefinite integral for arc sine x dx. That being said, I would think about ILATE, which is the easy way or the acronym to remember integration by parts. Here for inverse trig, right away you see arc sine, so I could say inverse trig, I see it, so let's let u be arc sine x, and then du, if you know about arc sine, would be 1 over the square root of 1 minus x squared. And then we'd say whatever's left over, let that be dv, but you might be arguing that there's nothing else besides the arc sine. And for that I would say there actually is, it's just the dx. And if you were to integrate dx, or find the entire derivative for just dx, this would just be 1x. So if I was going to put it all together, I would say the integral for arc sine is u times v, or x times arc sine. So I've got x arc sine x, and then I got to subtract away v du, which should now be x times the du, which is this 1 over the square root of 1 minus x squared dx, which you could say is now x over the square root of 1 minus x squared dx. That being said, now you look at this integral and try to find the antiderivative for it. You could say it kind of does look like arcsine, which is not a surprise since that actually is the derivative for arcsine. But since there is an x in the numerator, you could say maybe this could be done with just regular u sub. So that being said, I would probably do a little squiggly line and then set up a little u sub. Maybe say let u be the composition or the function inside of the function, which in this case is going to be that 1 minus x squared. Du in that case would be negative 2x dx. Then dx would be du over negative 2x. So that being said, if we know dx is du over negative 2x, that would cancel the x in the numerator and the x that we're dividing by here. But notice we also have negative 1/2 that we need to pull in front or become the coefficient for the integral. But since we already have a negative here, negative times the negative 1/2 would be a positive 1/2. So here we can say x times arcsine, x minus the negative, which will turn into a plus. We'll call this half. We have the integral, and then it's 1 over u to the 1/2 du. You could also call this u to the negative 1/2. The antiderivative for u to the negative 1/2 would be 2 times u to the 1/2 power. Remember, you've got to raise it up by 1 and then divide by that new exponent. So if we divide by a half, that would actually be the same thing as multiplying by 2. So we could say a final answer here would be x arcsine x plus 1/2. And then we've got times 2, and then u to the 1/2, which is this 1 minus x squared that we designated. If it's to the 1/2 power, we could say it's the same thing as the square root, so I'll say times the square root of 1 minus x squared. And then since we did cross out the bounds, we made it indefinite, we do want to put a plus c. So at that point, you could say the 1/2 times the 2 is 1. So in terms of a final answer, let's call this x arcsine x plus the square root of 1 minus x squared and plus c. And this would have been the last example that we completed on Thursday. So I will make one more video about the stuff that we did on Friday, and then that would actually complete the stuff that we did in class. And then I'd ask you to try to complete the assignments and bring any questions that you have. We probably will spend one more day on Monday talking about integration by parts before we move on. So one more video to come. Thanks, guys.